continuing the adventure of a lifetime. Just kidding. It's not that exciting. It's just the graph of cosecant and secant. Okay, well, let's start with cosecant. Cosecant is what? It's the inverse of sine, okay? So cosecant equals 1 over sine, the inverse of sine. So we could imply from that anywhere that sine equals 0, cosecant will be undefined and therefore have a vertical asymptote. So that translates directly to there are vertical asymptotes at the x-intercepts, because that is where y equals 0. So the x-intercepts of sine, of the graph of sine. Make sense? If not, tough muffins. I think that's a new catchphrase. All right. There will also be points in the graph of cosecant at the max and min. So the maximums and the minimums of sine, or the crests, since it's a wave, if you remember that, of sine. Sine. Let's just say sine. Okay, so first I will graph sine, and then on top of that, superimposed, if you will, I will graph cosecant. Okay, so remembering our sine graph, say this is one, just plain old sine. Y equals sine of x. Okay, it has a period of 2 pi, so let's break that into 4 bits. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, starts at 0, 0, goes up, goes to 0 there, goes down. Why did I write 2 here? That is clearly -1. Okay, so it goes, woo, partay. Something along those lines. Okay, and this this point here being pi over 2, 1, and this is pi, x equals pi here. This is 3 pi over 2, -1, and this is where x equals 2 pi. Okay, let's go to the graph of cosecant. Trying to make a joke in my head, but it's not working. Okay, so vertical asymptotes at the x-intercepts of sine. Okay, here's an x-intercept. Bloop, 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 bloop. Vertical asymptote, and in the words of Gandalf, you shall not pass. Okay, that's good enough. Here's another x-intercept. Okay, there we go. And another x-intercept is another vertical asymptote. So we have points at the maximum and minimum of sine. So here's a point on the graph of cosecant, and here's a point on the graph of cosecant. Now what do we do with those? Well, just make a little parabola. That's all there is to it. You don't have to be precise unless your teacher really wants you to, and that would be a pain, but you could do it if you just plug in the numbers. Okay? So this is basically our graph of cosecant. I mean, if you take out the sine graph. So let me do it again without sine so that you will understand. Let's see, y equals, in green, y equals cosecant x. Okay, now this is just plain old y equals cosecant of x. And oh boy, that's a horrible graph. Divide it up into pi over 2, pi, 3 pi over 2, 2 pi. Okay. So here at pi, and here at 2 pi, and at 0, we will have vertical asymptotes. Look at that. It just corresponds nicely. Just look at it. Okay, and 1, -1. We know there's a top of the sine wave at 1, and at -1 on 3 pi. I did this differently on both sides. Here's -1. Forget you. Forget you. That's like a song, isn't it? Forgive me, I'm culturally uncultured. Okay, so we have pi over 2 is this x coordinate, and 1 is the y coordinate. This is 3 pi over 2, and negative 1. Isn't that great? So we have a graph of part of cosecant. Isn't that just spiffy? Yes, and you will have it opposites over here. The period is still 2 pi, so you will have way over here at 5 pi over 2, you will have a point, and it'll go like this. We go over here, this is 2 pi away from 3 pi over 2 is negative pi over 2 right here. We'll have a vertical asymptote at negative pi, and we have a point here. This is negative pi over 2 and negative 1. All right, so that is 2 cycles of cosecant, the graph of cosecant. So this right here is just 1, okay? This is not 1, this is 1. And this is what I taught my students wrong when I taught them this. This is 1, and it has a period of 2 pi, okay? Just like sine, except inverted. Okay, let's go to secant then. Secant is the inverse of cosine. So y equals secant of x. So it's the inverse of cosine. So it will have vertical asymptotes where cosine, the graph of cosine has x-intercepts. So actually this is basically like the cosecant graph, except it's moved over pi over 2. Just like cosecant and cosine and sine are the same, except moved over. Max and min of cosine. And once again, period of 2 pi. So let's take a look at the graph first of y equals cosine of x. Y equals cosine of x has a period of 2 pi. It starts at the 1 instead of the 0. 1, 2, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, it goes there. What is this? 2 down. Here, here, here. Okay, so it's going to go sound effects. All right, so x-intercepts of cosine. Actually, let me label these. This is 2 pi. Oops, 2 pi over nothing. 2 pi, let's make it a point. 2 pi 1. This here is 3 pi over 2. This is pi negative 1. This is pi over 2. This is 0, 1. Okay, now we can do secant. So the x-intercepts, we have vertical asymptotes on secant. X-intersect, vertical asymptote. And let's have a pi over 2 over here. Negative pi over 2. Negative pi over 2. The vertical asymptote. And then we have the same point shared, but then it goes off and does its own thing in a nice little parabolic motion. I love parabolas. All right. There's that. So let's do green is y of secant of x. Let's just do a graph of secant of x by itself for kicks and giggles. Write it again. Okay, so what do we have? Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we have an vertical asymptote at pi over 2, pi over 2, have a point at pi negative 1. We have another vertical asymptote at 3 pi over 2. And we have another point at 2 pi 1. And it's 0, 0. Or 0, 1. It's a winking owl, you see. And negative pi over 2. And then we draw our little parabolas in. Easy peasy. All right, there you go.